Hello, everyone, and thank you so much for coming. Welcome to our IBM Developer Black History Month event, Ethical AI, Bias in Visual and Voice Recognition Software. I will be your host for this evening. My name is Jenna, and before we get into introductions, I just want to go over a few pieces of housekeeping before we get started. First of all, if you scroll to the very top of the chat, you will see that I have listed an IBM Cloud signup link. I've also listed the URL to the Google Slides that you will have access to. This event is being recorded, so the live stream recorded will be available at the same URL that you joined with today, immediately following the event. So if you join or want to share the event at a later time, you can share the same link you joined with today. I've also included the AI Fairness 360 Toolkit and a few recommendations for some data science badges if you're looking to start dabbling in a little bit of data science. So thank you all so much for coming. Looks like we have people joining from Mountain View, South Africa. We have a few people from Canada, Chicago, Austin, Detroit. Very cool. There we go. Okay. So since you're all now part of the IBM Developer community, I want to give you all a chance to get to know each other a little bit better in the chat, since we don't have the luxury of doing events in person at the moment. but at least we can connect with each other virtually over the chat. So first, let me introduce myself, and then feel free to introduce yourself in the chat if you would like. My name is Jenna. My pronouns are she, her. I'm a cloud developer advocate for IBM. I am joining from, and I'm also from Detroit, Michigan. I'm currently part of the New York City team, but we're kind of all over the place. So I've been in Austin with IBM for the past few years. Something that I love are my dogs. I have little Yorkies. We may or may not hear them scratching on my door and crying in the middle of this. Hopefully we won't. But they're definitely the most exciting part of my day, especially since quarantine, and a quirk. So something that's uniquely different about me. If you've come to one of our events before, you've probably heard this. I have a weird obsession with tuna sandwiches and tuna melts. And I judge everything on the menu at a restaurant based on how well a restaurant decides to make their tuna sandwiches. I feel like if they don't put enough love into it, they're probably slacking on some of their other food as well. So that's a little bit about me. Feel free to share a little bit about you in the chat. Again, as I mentioned, all of these links are available at the very top of the chat in the Crowdcast chat. I'll also be sharing these with you at the end as well. So we have the link to the slides. Again, the live stream recording will be at the same link that you joined with today. I've also included the a link to the AI Fairness 360 Toolkit, which we're actually going to be deep diving into a little bit more at another workshop later this month. If you're looking to dabble a little bit in data science at all, here's a link for an IBM Cloud sign up, and you can sign up for a free cloud account and use any of our Watson Studio services with our light tier account. So this is what the login looks like. So if you're looking to connect with me following this event or access other workshops and content that we've done this year and last year, feel free to connect with me at jwritten on any social. It's at jwritten, pretty much on every social platform. So now to the important part. I would like to introduce our wonderful panel here. If any of you are joining from Austin or have heard about what's going on in Austin, there's a lot of people without power. There's a lot of people without water. There's a lot of people without both. So we've had some, last minute changes to our panel, but that's okay. We're still going to have an amazing event. So I would first like to introduce our first panel speaker, Dr. Anton Flowers, who's a data scientist at Google, and I'll let him introduce himself and tell you a little bit more about himself. Oh, there you go.
Figuring this thing out. Hey, how's everyone doing? My name is Antoine Flowers. I am from Chicago, Illinois. I guess I always start with that's the most exciting part about my bio. I am a data scientist on the revenue acceleration team, actually in neuroscience. Transitioned and spent some time in fintech before showing up to Google. A big part and focus of my work there is learning how to integrate powerful ML systems that work alongside humans and not replace them. How do we amplify the things that we can do naturally to future-proof this type of work? So that's a little bit about me. HBCU graduate, Tuskegee University, and can't wait to talk to you guys about this really important topic.
Thank you so much, Antoine. Our next panel speaker that I would like to introduce. Hello? Oh, can you hear me?
Hello?
Yep, I can hear you. Can you hear me okay? Okay.
Looks like I'm here.
Okay. Thank you so much. Our next panel speaker, Dr. Fatima Tarlasi. So Fatima is without power right now in Austin. So sadly, she couldn't join us, but she did share some amazing resources for all of you that we will be going over later. Yeah, we can still see you, Antoine. Let me just check here. Yep, it says you're still on screen. Yeah.
Yeah, I can't see or hear any of the other speakers. Everyone looks frozen.
Try to refresh. Oh, hold on.
Okay.
Make sure that I'm connected well as well. Perfect. Are you able to hear us now?
Yes. Yeah, it was weird. I was there by myself for a second. Sorry.
No, that's okay. Okay. Yeah, so and for anyone joining too, if you're having any issues with Crowdcast, good rule of thumb is just refresh your browser and usually that fixes it. But if not, feel free to message in the chat or ask any of us for help. So again, sadly, Fatima couldn't be here. She joined us last year for our panel. It was a really great event, but she did share some really great resources that I'll be sharing with you a little later. Our next panel speaker is Mike Hollinger from IBM, and I'll let him introduce himself and tell you a little bit more about him.
Thanks, Jenna. So my name's Mike, and I'm the chief architect for our computer vision platform and also time series data coming into some of our asset management software. I've actually worked in a bunch of different parts of IBM and have always been the little bit out of step person within the team as a software person amongst the hardware team or the AI person amongst the application teams. I look forward to sharing a little bit more about the unique nuances of what it really means to be, fair in data or fair in AI models with everyone here later today.
Thank you so much, Mike. And our last panel speaker, so Mary, I know that on the event we had Mary Haskett from Blink Identity. She is without power. So her co-founder and CTO at Blink Identity with her, Dr. Alex Kilpatrick, is going to be joining in her place and talking about bias in facial recognition software. Alex, why don't you tell us a little bit more about you and introduce yourself? Oh, you're muted.
Yeah, I'm muted.
I do it. Got it. Hey, everybody. My name is Alex. Yeah, my PhD is in computer engineering from the Air Force Institute of Technology, which is kind of like the Air Force's grad school. I used to be an Air Force officer. I used to manage research and development in computer science at universities. About 15 years ago, I left the Air Force and started doing work in biometrics in the Middle East and helped both Iraq and Afghanistan develop their own biometric capability to do background checks and things like the FBI does now to help make all these places more secure. I've been working with the application of face recognition and biometrics to identity over that whole 15 years. So this is a topic that I'm really interested in and we've had a lot of experience with. So I'm looking forward to talking about it today. Blink Identity is a company we formed to stop doing defense work because we didn't want to go to the Middle East anymore. And we focus on opt-in commercial face recognition for access to live events.
Very cool. Thank you so much, Alex. So before we get into our first talk, so our first talk is going to be on visual recognition with Dr. Alex Kilpatrick. So before we jump in, if any of you are looking to start looking into data science, dabble a little, get your feet wet, See if it's an area that you'd like to learn more about or deep dive into, or maybe study. IBM has some really great badges and really great coursework through Acclaim. It's completely free to you, and with each badge, you're actually learning 3 individual data science foundational badges in order to earn the cognitive class badges. So these are things that you can add to your LinkedIn. You can, market yourself to potential employers that you're interested in learning the foundations of data science, and that you're actively, educating yourself in areas you're interested in and pursuing careers in. So our first badge is the Data Science Foundations badge. And then the second badge that is the next step forward after the Data Science Foundations badge is the Applied Data Science with Python. And again, there's multiple courses and badges. I think there's 3 courses per badge. And the Applied Data Science badge allows you to really start getting your hands dirty a little bit with some data science applications. So I'd highly recommend. Again, it's completely free to use. It's only to your benefit. I've done a number of our badges as well as an IBMer, and I think they've been really helpful. So wanted to recommend those. And let's go ahead and get started with our first talk. So I'm gonna let Dr. Kilpatrick take over. Stop sharing here.
Okay, can everybody see that one okay?
Oh, nope.
It says your screen sharing, but I don't see the presentation.
It's sharing your broadcast screen.
Okay, let me try again. Yeah, I should be sharing the actual. How about now?
Yes, perfect.
Okay. All right, great. Hello, everybody. Yeah, I wanted to basically, this is just be a short talk to kind of introduce this area for later discussion, but I wanted to kind of cover some of the things that we see when we see people talking about bias and things like that, specifically in face recognition. We also do work in iris recognition and fingerprints. There doesn't seem to be any significant bias in those. They're just kind of different demographics. But one of the things we see a lot is people are afraid of face recognition, and there are definitely areas to be afraid of in face recognition. It's a technology that can definitely be used by an Orwellian state and violate privacy and everything else. But so are a lot of other technologies in history, and I've listed a few here that historically have been seen as extremely negative for society. The phonograph was a way to preserve bad music forever. Databases were going to make people just a number. Cell phones were going to end work-life balance. All of these were predictions about how these technologies would be negative for society. And for the most part, they all came true, which is kind of interesting. But the more interesting thing to me is that we figured out a way as a society to get around all of these. We decided that the technology is useful. We'll figure out how to integrate into society in a way that everybody can live with. As a society, we've almost never taken a useful technology and just decided to ban it and get rid of it entirely. That pretty much never happens. So when I see stuff about face recognition being dangerous, I both agree and disagree with the concept that it makes sense to get rid of it entirely. As I mentioned earlier, we do opt-in face recognition, so we're very strict about that. It's an important part of our culture. We think face recognition should be something that does something for you, not something that's done to you. But as we see people talk about face recognition in the media, and especially online, there's constant discussion about racism and whether the technology is racist. And as an engineer, this kind of terminology has always been difficult for me because race is a very complex concept. It's cultural, it's somewhat demographic. It's just very, very complex. It's not what we would kind of consider generally an engineering topic. So in the biometric community, we tend to avoid the more emotional laden terms like racism and focus on things that we can measure. And one of the things we look at is demographic bias. It's just a different way to measure it. So what we're saying is, are there differences in how the different algorithms perform across gender or skin color or age or geographic location? All things that we can measure precisely to understand how these algorithms actually perform. There's a couple of terminology things that we have to get out of the way just to make sure we're all on the same page here. In any kind of classification system, whether it's a medical test, face recognition, fingerprint matching, anything that where a computer is classifying something, there's two types of errors that can be made. They're generally called a false positive and false negative, but because we work in areas where it's not always clear what's good or bad, law enforcement versus access control, we tend to use the term false match and false non-match to make it more clear. So false match is when you incorrectly match the wrong person in a database. In a law enforcement context, that could lead to a wrongful arrest, which is obviously really bad. But it could also allow you to access an office or an event that you shouldn't be allowed to access. So a false match is generally tied to more of a security type implication. A false non-match is when you should match somebody in the database, but you don't. You can't unlock your computer, you can't get into your office, that kind of thing. These are generally seen as more of an annoyance. In a law enforcement aspect, you're released when you probably shouldn't be released or whatever. So all of these things are errors that these kind of systems can have that we need to measure to understand demographic bias. There's a third type of error that we run into that is kind of a footnote to all of this, and we would call this a failure to acquire, which means we can't find a face in a scene at all. That's usually done because of the camera's really misconstrued or something, or misconfigured, or there's a really bad lighting situation, but it's really a different type of error than the other two that we're talking about. In face recognition, there's two types of ways that it's done: verification and identification. Verification is when there's already a claim made, and this is what happens if you unlock your phone with your face. You've already made a claim to the phone, you've already registered your face, and you're asking the phone to verify, is this me? Am I the one person stored in this database on my phone? That's verification. It's a much simpler problem than the one that we usually deal with and most face recognition systems do. Identification is, I have a face and I have a big gallery, we call it gallery, a background database of faces, and I want to know whether this face is in that gallery at a high degree of confidence, ideally. It turns out that there's actually things in face recognition, depending on it's very contextual depending on what you're doing, and that will affect what the results mean and what the errors mean and what kind of errors you have and everything. Famously, a few years ago, there was the police scanned everybody at this major this major sporting event. Millions of people were scanned, and they had around 2,500 candidate matches, most of which were false. Only 173 out of those were true matches. And this was kind of seen as an issue with the police use of face recognition as a general scanning mechanism. And at Blink Identity, we don't actually think this is a good use of the technology. Part of the reason is because of conditional probability. There's a big difference in how a system performs when the person you're searching for is not in the database, most likely in this case, the criminal database, versus one like ours where they most likely are in our database because they've opted in. Those change the whole probability and how everything works out of this dramatically. So it's an important impact on how these different technologies should work. And generally, because of the rarity of finding criminals in a large crowd like this, any system, even a very accurate system, is going to be deluged with false matches. So the national organization that kind of looks at all this, that's essentially the gold standard independent, is the National Institute of Standards and Technology. And they have an ongoing test. It used to be every few years. Now it's just essentially constantly ongoing, where they look at around 200 different algorithms from different vendors for accuracy, speed, demographic bias, whether they work with masks, usability, quite a few different tests. They've been doing this test for a long time. And their current database is working with, their current test with the demographic biases with a database of around 18 million, which is huge, much bigger than any commercial private organization has outside of somebody like Facebook or Instagram or something like that. And they test over 200 different algorithms. And it turns out that's actually pretty important. We see a lot of stuff in the news that is essentially cherry picking data out of NIST to be able to make a certain point. So one of the things that the NIST report, and I'm not kidding here, has 1,200 pages of graphs just on demographic bias alone. That's not counting accuracy and performance, just on demographic bias, 1,200 pages of graphs. So it's a lot of data for anybody to understand. But essentially, the key things that I think are important out of the NIST study is that there is some pretty huge demographic bias, but it depends a lot on the algorithms that you're looking at. If you look at the worst algorithms, the ones that were down at around 200 or 180 or whatever, they had false non-match rates as high as 99% with dark skin faces. But the top algorithms, I'm talking about the top 20 or so here, had what NIST called undetectable false positive demographic differences. And you can see some of the numbers here. These are the actual false positive rates for these two different demographic groups. But the trick is this, is you can kind of, NIST will say that these are essentially undetectable false positive differences. I've seen headlines that'll point out that Black females are 3 times as likely to have a false positive as white males. Both of which are true. It just depends on how you're interpreting the data. Also, not really significant false negative differences as well in most of the algorithms that are out there. This mirrors what we've seen in practice. Our systems are operational in a couple of different places right now. We're still a startup, but we've done hundreds of thousands of transits and tens of thousands or 20 to 30,000 unique enrollments. And we, across all demographic groups and ages from 8, I think, up to around 80. And we don't really see any difference at all. But we do a lot of work to basically improve the quality. That's the other thing that came out of NIST, is that as the quality of the image goes down, you tend to have a lot more likely false matches. So that's one of the things that makes all of this stuff contextual. To understand the results, you have to understand the context of how a system is being used. But in terms of what I'd kind of like to share for the group, or open for discussion if you disagree, is the key things that I think we take away from this is that banning face recognition is probably not going to happen. I don't think anytime soon. We can control it, but we can't ban it. It's too much out there. It's too handy for our iPhones and a bunch of other things that we want to do. We just don't have a history as a society of banning technologies. But I do think we can figure out how to make it work. When I see people talk about an algorithm having bias, I kind of agree and disagree, because every algorithm has a bias. It's just how these kind of classifications and neural nets work. There's going to be some bias tied to the training set. We always try to minimize that. And with face recognition, we see biases on both sides, of the fence. So that kind of tells us that we're getting close. You're never going to get an algorithm that's exactly the same on every different demographic group. But we can have algorithms that are pretty much independent of demographic groups, or they bias one group over the other enough that they flip-flop back and forth, that it's probably about as good as we're going to be able to do. The other thing about this is that you have to look at what is the application being used for. A law enforcement application where somebody's going to be arrested is obviously way more important than an application like ours where somebody might get into a concert for free. The context matters a whole lot in what we're doing here. The other thing that is important to understand is that things that are outside of the control of software can affect how people match, at least with face recognition, and to a degree iris and fingerprint as well. Optics, lighting, camera, all of these things will have an impact on darker skin faces. And that's essentially just the nature of optics and light reflection and things like that. These are all things we try to minimize as much as possible, but they are just physics that we can't get away from. And then, to reiterate my last point, there is no one thing that's face recognition. There's face recognition used by law enforcement for some good purposes, some really terrible purposes. It's misused in a lot of places, but it's used properly in a lot of places. And the key thing is that the demographic differences that we see are minor at best, and we're able to manage them enough to make applications that are useful and solve real world problems. And that's all I have.
You're on mute.
JK. Okay. I wanted to spend just a few minutes on questions that are specific to the topics that you've just talked about. So we have just a couple questions here. The first one we have is, someone said, I've read that facial recognition struggles with persons of color. Is that true? Is that a case of training data being biased, or are there other factors at play? Oh, you're muted.
This mute thing.
Actually, I kind of prefer talking about persons of color more than race, because that is actually a physical property that does affect matching. The darker your skin is, in general, you're gonna have a little bit more difficulty in matching. We don't see any significant variations among dark skin to light skin faces, and NIST doesn't in the top algorithms. Lower algorithms have that bias, but we generally don't see any difference between dark and light skin and their ability to be matched.
Someone else asked. Oh, sorry.
Okay.
Someone else asked, Won't an increase in diversity lead to a decrease in the advent of racism in AI?
Yeah, I mean, I think the interesting thing is that everybody I know in the community always wants better training sets. And it doesn't matter if we're doing face recognition or product identification or anything. We always want more diversity in our training sets because it makes the algorithm better. I think there are, some aspects of this that can be troublesome. There was the issue of Google using a machine learning algorithm. Sorry to slam Google here. I think for HR where they it ended up biased towards males, on resumes and things like that. I mean, all of this stuff has to be carefully considered when you build training algorithms and things like that for your data sets. But in general, the algorithms have been improving dramatically over the last few years in terms of the amount of diversity they have of their data sets. And you can see the corresponding improvement in their performance. But we're down, again, now at talking at differences of 1,000th%. Very small.
And before Dr. Antoine, you go ahead and take over for your talk. Mike, do you or Antoine want to kind of add anything or contribute to the two questions that were asked, or kind of what Alex has been talking about?
I think you were spot on. I think your responses are completely accurate. One of the diversity questions struck me like they might be asking about diversity in engineers. And I'll kind of talk about that in voice recognition. That's incredibly hard, especially when you start talking about voice recognition, because we're so different from rural America to New York to the 27 different dialects in Nigeria so really it is about diversity in the data set.
Mm-hmm. Yeah, and somebody did ask about human face recognition, which is a good question. That's been studied. Human face recognition is actually really terrible. With trained examiners, like passport examiners, if they're biased to know that there's going to be imposters, they tend to have around 12 to 15% false match and false non-match rates. So humans are really good at recognizing your loved ones, your kids, close people like that. They're terrible at regular face recognition, and humans, even at their best of days, are going to be more biased than computers.
So Alex, let me ask you something, kind of zeroing in on something a little bit here. You actually said in that NIST study that the algorithms were getting really good, but you also said, hey, we always want better training data sets, right? I think we should probably talk at some point about the difference between the model and the algorithm and the data set, because that's a big piece of the source of bias, or the source of what differentiates really great technology from not so great technology, right?
Sure. Yeah. I mean, I get the impression when I talk to people about this is that they feel like the implicit bias of the programmer could spread itself to the algorithm. And I mean, I don't think anything it could possibly be in the selection of the training set, but that's about it. I don't see how else it actually manifests itself. But
that's kind of what we see as well. And I think, especially in the face area, like a good example of this, right, is you with what you are doing. Could you maybe talk a little bit about the difference between detecting, is there a face there, from, is that Alex's face, right?
Yeah. I mean, those are actually completely different steps in most pipelines.
Right.
And they don't even have to be compatible. Yeah. I mean, we call it face finding in general. And that one is, I mean, I don't really know how to address it. I mean, they're just such fundamentally different problems. And face finding is just amazingly sophisticated now. If you use your iPhone or whatever, it will pick up faces and all kinds of cluttered backgrounds and all kinds of stuff. But well, we tend to operate a lot in really low light conditions, and we use non-visible light to enhance that. But in areas like that, that's where you're going to tend to see some of the failures. Is if it gets really dark and you're dark skinned, it's going to tend to break the face finding. And if you look at the stuff where people have been trying to intentionally break face rec, which is another interesting field, that's how they always try to break it. They don't try to break the matching; they try to break the face finding with like camouflage makeup or things like that.
Oh yeah, no, actually, I saw something just the other day on like IR lights just on a hat or something like that, right? To try to overwhelm the camera.
Yeah. And there's things like makeup to kind of they call it CV Dazzle to kind of break up the lines of your face and things like that. And we've experimented with those just to see how sensitive we are to face makeup that we might see at a football game or something. But yeah, so it's kind of interesting because I think that's where we tend to see most of the failures is in face finding. And it's usually caused by user error, like they're looking down at their phone or they're not walking in our capture volume or something like that. We don't really see actual biometric errors happen. And they just tend to not happen, except with twins. You know, twins are always going to be a problem with face rec. But.
Well, thank you so much. And so now we're going to move on to Dr. Antoine Flowers' talk about voice recognition software. So if you want to go ahead and share your screen, you can go ahead and do
Everyone
that.
see it?
Yes, we can see it. And we'll get to more questions as we go. So just no worries, have some patience, and we'll have plenty of time.
Sounds good. I was wondering if this thing auto mutes us sometimes.
Maybe, I don't know. It does what it wants sometimes.
All right. So it seems like people in the chat are pretty savvy. So I'll kind of adapt my approach to that. So speech recognition and voice recognition models historically have consisted of two components. So when we talk about bias in these models and algorithms, we have to understand that there are kind of two components where that can occur. Early on, when there was things like Dragon Natural Speaking and Dragon Natural Language, what we really saw was this big push for speech to text. And a lot of that was, well, those were the early acoustic models. And essentially what these early acoustic models would do is they would take this snap of sound, and later algorithms would actually try to identify the difference between the phonetic components of the sounds and you taking a breath. And from that, you would get things like intonation or pitch. And so that's the difference between somebody in Chicago saying "ka" and somebody else saying "car." You know, so those differences in intonation and pitch can actually themselves contribute to bias in acoustic models. And when we talk about this, the easiest way to recognize this is, you know, you're talking into your Google Assistant or your Alexa, and it's kind of streaming the words as you say it, and you're seeing that, okay, when you first say the word, it actually gets it wrong, but maybe when you say a couple more words, it corrects it. But that correction actually has to do more with the language model than it does the acoustic model. I mean, we'll kind of talk about how these two things come together here in a second. Now, it's important to understand how these acoustic models are trained and how they came to be. And it's also important to talk about how the language models were trained, but we talk about that a little bit later. Early on, at least at Google, when a lot of these acoustic models were being trained to improve our speech to text, what was actually happening were we were getting people to opt in to share their voicemails. And so obviously you're going to have, you know, people of a certain socioeconomic class comfortable with doing that, probably geographic specificities when you have people doing that. And then there's also, you know, the issue of you don't have people that don't have phones. So that's a very first world, you know, training set that we were getting in order to create these models. The second part is dialect here, and intonation and tone is so different. Even if you look at the Creole, you know, the Creole dialect of New Orleans and, you know, somebody from Brooklyn. So you really need a massive corpus in order for this to be equitable and work across a large number of people. And then you have the Western European versus the tonal languages. That's a completely different problem set, right? Because English is not generally a tonal language, but when you start going to places like Africa and some parts of Asia, and you have these, you have this extra element of language here that not just adds to the context and complicates the language model, but also complicates the acoustic model. You can start to see just how complex and difficult this problem really is. The second part of speech recognition models have always been the language models. So now when you read a lot about bias in speech recognition, especially the work of Dr. Timnit Gebru, you're really hearing a lot about language models. And this is essentially an outskirt or a growth of, you know, NLP techniques like skip-gram and word-to-vec. And I'll talk about that in a second. But really, these types of algorithms started with well, the acoustic models have always kind of been probabilistic. So, Gaussian mixture models, Bayesian models, they evolved into deep neural networks. And now, and the language models generally have always been this embedding style of technology. And so we'll talk about this a little bit more here. So this is an example of a spectrogram. So when we look at speech to text, this is essentially what the device is picking up or capturing when you're first speaking. And essentially what it's doing is it's trying to isolate these different phonetic sounds. So if I say rabbit, bit, there's going to be 3 different phononyms, and then it tries to identify what those phononyms might be using some type of probabilistic model. So that's the acoustic model component of it. And then pronunciation, once again, pronunciation here makes a big difference, because when we're talking about speech, all we really have is frequency and amplitude. So the difference in how we say words really come down to those 2 different components. But if you think about all the things that can influence those components, you could have somebody with neurodegenerative disease. You could have the fact that women have shorter vocal tracts than men, which is why our voices are deeper. You could have people with different tonal accents. You could have people that use certain types of slang. All of those are going to impact kind of these spectrograms and their ability to actually identify what it is someone is actually saying. So the evolution from these kind of 2-component models, where I had a speech acoustic model and then a language model, actually, started to move closer to one unified model around 2012, 2014, when we started to see some of these more advanced language models and deep neural networks, deep neural network architectures come into being. So what we're looking at here is your classic autoencoder. So your encoder decoder architecture, where your inputs are actually going to be the phononyms themselves. So this is actually going into a recurrent neural network, which is a type of neural network that can receive sequence data. So, things that come one after another, like language or time series or something like that. So the words are encoded here, and then they're decoded in a different part of the neural network. This actually represented a kind of revolutionary step and a massive improvement in the accuracy of voice recognition technology. And this happened around 2014, between 2014 and 2016. But this coincided with kind of this acceleration and development of these massive language models. And so essentially, we'll talk about that in the next slide, but this is kind of the precursor. So this sequence to sequence technology actually allowed us, instead of having to break up word by word by word, we're taking in or feeding the output of an acoustic model to a language model. We're actually taking in the sound itself and translating that to some type of meaning, some type of output that actually has meaning to it. So, these models offer tremendous accuracy. The primary drawback to these is that the entire word sequence needed to be encoded before the meaning was provided. So if you think back to that time when you were talking to your Alexa or whatever you had in 2016, oftentimes you have to finish the entire sequence. A couple of years ago, Google actually rolled it out so that now as you're talking, you can see your words coming up and it translating in real time. That type of real-time sequencing wasn't possible until this type of technology came out. And then we came, and now the kind of the state of the art are these recurrent neural network transducers. So if you're not really savvy in AI, excuse kind of the tech talk here, but really this just represented the next evolution of these sequence to sequence models. And these are what allow us to continually process words. So the reason that I came through all of this is because I wanted you to really see and understand just how difficult and complex it is to train these models. So when we talk about bias, one of the issues is that a diverse group of people or institutions or entities really aren't capable of training and creating more diverse models that do this, right? It costs in the order of millions of dollars to train a massive language model, just because of the amount of computing power that you need, the amount of computing power that it takes to operate this recurrent neural network. It actually requires and is dependent on this proprietary Google TPU or tensor processing unit hardware. That's the only way we're able to do this kind of real-time transcription decoding. And so this in and of itself puts this very powerful technology essentially in the hands of very few multinational corporations that actually have the hardware and the underlying capital to do it. So you have 2 constraints when you talk about making ethical and fair voice recognition technology. You have the first constraint, which is the data set and the massive amount of data that you need, not just in the acoustic models in order for it to be equitable, but also in the language models that you need for it to be equitable. And then you have the technology constraint. Then in and of itself, it's very difficult to kind of reproduce and train new models that can operate in this space. And so really it is up to the larger companies to kind of take this on and solve these problems. And so when we talk about language models, this is kind of what's on the forefront. So these language models are essentially very, very, very big word embeddings. And if you're not familiar with word embeddings, essentially what we're doing is we're understanding the context of a word based on the natural structure of our sentences. So the context of the words around it. If you can think like, I'm going up to the bowl, that could mean a lot of different things. So if you're out skiing, I'm going to ski in the bowl. Or if you're out, if you're in Chicago, you might be going to the bowling alley. That's not a very good example, but we can think of a lot of different, a lot of those examples where, one word or one phrase has a completely different context, not just based on, the words around it, but who's saying it, the region it's being said in, the language that it's being said in. And so, the complexity of all of this is actually kind of baked into these very, very big language models. And one of the biggest drawbacks and flaws of these things is BERT, for example, that's actually trained by Google, is trained on all of Wikipedia, all open source books, all open source media. And one of the issues is that you're ingesting a lot of biased data, right? So if you think back to, the late 80s or early 90s, or if you know anything about that period and what was happening in terms of criminal justice in the United States, there was the crack epidemic. So if you're ingesting data from that time, even if it's research from that time, it was all biased towards this idea of Black criminalization, Black people as drug dealers, minorities in this high context of crime and drug use, which we now know was kind of like this half-baked media, not just a media thing, but also in kind of conjunction with the government. And so when we think about all of these issues, even pulling, reputable research from that period is gonna have the bias of that time. And it's really difficult to kind of get around that. But in order for these language models to work within so many different contexts for so many different people, you really have to bring in massive amounts of data. And so it's a lot harder to kind of pull that out. And it's also a lot harder to identify where it surfaces because there's so many edge cases. There's so many long tail edge cases here that you can't really identify them all up front. You can think of some big ones, but there's so many different use cases for this technology. It makes it relatively difficult. So the evolution of natural language processing, like I said, actually started with things like skipgram and bag of words. But then as we started to move forward, now we have these really, really big language models, which are essentially a collection of embeddings or context for words within the context of other or surrounding words. And this is actually the underlying thing that powers a lot of the voice recognition technology today. And this is where a lot of source of the bias is actually going to arise. And so some of the pros I just talked about, first of all, these things have really revolutionized voice recognition. The fact that I can ask my Google Assistant just about anything, even things that are really specific to my context, like, hey, call my wife. And it has the ability to actually understand the context of who's speaking to it, based on some post training that it's done and what my wife means within that context. If you just think about how fast these technologies have come in the last 5 years, it's kind of mind-boggling, but it's come at a price. And that price is that we've really rolled out these biased models really ad hoc. And so the other thing is these are pre-trained models that don't need to be trained again. And so they can be used by anyone that understands how to use AI or deploy AI. And those, end stage users probably aren't checking for bias in the language model that they're using. Hopefully they would. So some key ethical considerations here. We talked about the representative language models. It's really difficult to get a really representative data set, especially because we're really based on what's been digitized, and a lot of that's in the first world. So the second and third worlds, places where a lot of those documents haven't been digitized, they just don't have a lot of the context for their language in a place where it can be put into a model or a training set. And then the other issue that you have is in a lot of places in the world, a lot of history is still oral. So it's not been digitized, it's not been written down, and it may unfortunately be lost. The other issues here are accuracy across racial and ethnic backgrounds. So research from Stanford has actually shown that voice recognition can be up to between 10 and 20% less accurate for people of color. But it can also be less accurate for people, white Southerners. So really, it's not a purely racial problem here as much as it is a minority issue. So anybody that is not kind of middle of the road with your dialect and inflections is going to have some trouble with these models. The other thing that we mentioned here was accessibility for researchers, high cost to train, high cost to test, high cost to really identify, the biases that these models have. And then access for speech impaired. So once again, if you're deaf or if you have a neurodegenerative disease, some loss of motor functions, you're really going to struggle to use these, because even if we could get, a large data set of people with a specific neurodegenerative disease, the way that disease impacts them is going to make their case that much more unique. And unfortunately, that's just a very difficult problem for us to try to solve by enriching a data set. And then some of the more kind of, what you would think were out there, but actually aren't, are the nefarious replications of someone's voice. So general adversarial networks, the things that are being used right now for deep fakes for video, can also be used for deep fakes for voice. And if you think about it, deep fakes for video are much easier in the moment, at least right now, to kind of detect. And then there's some artifact of it. But if someone is using your voice to impersonate you by calling the bank or calling a loved one or calling your job, that's really much harder to detect, and it's much harder to find out what actually happened in the aftermath of that. So there are some solutions in development. I will give you guys some time to kind of look at these. Project Euphonia is a big one at Google, where we're actually going out trying to solve the problem for people with speech impairments, gesture recognition for the nonverbal, and then methods to identify language bias is probably the largest area of focus. There's some obvious ones, right? Does it work for Blacks as well as it works for whites? But then when you say Blacks, well, what do you mean? Because the dialect in LA is very different from the dialect in Chicago, is very different from the dialect in New York, and the dialect in Brooklyn is very different from the dialect in Queens. So it's just this corpus enrichment problem is just such a massive one that it's gonna take a large collaborative effort to really solve it. And then I got some references for everybody, but yeah, that's my spiel.
Thank you so much. So before we get into our kind of guided panel discussion, where we'll then break out and start looking at some of our Q&A from the audience, I think we have a few questions that are specific to voice recognition software. So the first question we have here is, BERT is open source and GPT-3 is not. Is that correct?
Yes.
Okay.
For now.
Perfect. Yes, for now. Okay. Our next question is, percentage-wise, how much of the speech data used in these large language models is English of various kinds? And how much is how much is other languages? So since native English speakers are about 5% of the global population, and does that matter?
So there's this self-fulfilling prophecy that occurred when we first rolled out these models, right? So the more you use these models, the more training data we have in order to improve them. The fact that we rolled them out with a very select group of people meant that, English, American, Europeans, actually were the primary users of this technology, which means as the technology continued to develop, even though we were getting more speech data from more diverse groups, the best quality data that we had to improve these models on was still primarily white males from the United States. And that was primarily either from the middle of the United States or Northern California. And so that kind of had this snowball effect that even though we've now launched out into this global market to bring in more data, it hasn't really solved the problem because so much of this is already baked into the pie. And right now we're focused on, larger markets. So like India is going to have really good technology. China is going to have really good technology. But when you start talking about places like Nigeria, Ghana, it's just not going to be the case.
Very cool. Thank you. We have another question that I think maybe I think would be good for you to answer, and then maybe if the rest of our panel would like to give some feedback too, possibly. So the question is, where did it? I may have just lost it. Let me see.
I have one I can ask if you want. I'm kind of curious, how do you know when you got it wrong? How do you get your negative examples?
So early on when these models were being trained, a lot of it was kind of going through and manually labeling, what was incorrect. And so there was a lot of tweaking of the technology around that time where, without getting too technical, there was this attention mechanism where sometimes the model would just stop listening. It would think there was no voice there. So once again, you had the voice detection component of it and then the translation component of it, and you have to get both of those right. And so, a lot of it was absolutely manual. Now, with things like the voice assistant, we can actually detect and measure how many times that you retry a query within, a certain periods of time, and use that as a fail.
So I found my question. So someone asked, shouldn't most developers in voice recognition be given some form of a linguistic training to have a deeper understanding of the structure of language?
So a lot of them do. Okay, let me rephrase that. I know I was interviewing for a role at Google, and the role was to deploy these kind of generative NLP roles or generative NLP models out broadly. And they were looking for somebody that had backgrounds in linguistics for that exact reason. This was actually for our customer center AI. So right now we have, this really in Google Cloud, this really large AI contact center product that's rolled out to Verizon and everywhere else. And a lot of that is, based on our voice technology, and they are looking for people with linguistic backgrounds. The problem is, how many people is that, right? Like how many people are software engineers with interest in AI and also have a degree in linguistics? It's just not too many. So I think if you're going to go in that field, these big companies should pay for whatever training, and largely they will. If I wanted to go receive that training and focus on NLP, that's something that Google would compensate me for. But how many people work at Google? It's not a broadly accessible solution.
Let's see. We have I think one more question, and then we'll break out into our panel discussion. Do you believe biasness is an issue only in generative models? What about detection models like voice replay, AI synthesized speech detection?
Okay, so AI synthesized speech detection, I'm a little not clear on that. So synthesized speech detection, yeah. So when I hear synthesized, I'm thinking like general adversarial models that actually recreate speech. In terms of that, no, there's no real bias there, because in order for there to be bias, there has to be this large corpus of things that I'm trying to identify. In this case, really, I'm trying to replicate something. And so really, I'm just going back and forth until I've mimicked it perfectly. In terms of, so that's for generative models. I don't think, I don't think bias is an issue in generative models just because of the nature of how they're trained.
Okay. Perfect. Great. So let me share again.
It would be funny while we're talking for somebody to train a generative adversarial network to try to create a Black voice and see how racist that ended up being.
Oh, that would be terrible.
It's like I want a Black voice on my Google Assistant, and it sounded like Lil Wayne or something. People would be pissed.
I actually had Samuel L. Jackson for my Waze for a while, and I was annoyed that it wasn't, doing the full thing. It was just the concatenative speech stuff, right? Where it's just putting together a sentence to turn left or turn right.
Yeah, actually with our Alexa, make sure I'm not muted. I keep muting myself. With our Alexa, we discovered the Issa Rae voice. So we, anytime we ask our Alexa questions, she's, giving us the weather and the news and whatever information we ask it. But those are, they're recorded. But I understand what you're saying. It would be extremely problematic to try to construct a language virtually.
Yeah. I'm kind of curious. I know in FaceTrack there are algorithms that will detect race, which is a huge disaster in a lot of ways, But I'm curious if they do that in voice recognition at all, because it seems like you might be able to detect some aspects of it.
Well, so so I have much more in common with somebody, a Black person with my genetic background, right, is going to look similar to me no matter where they are on the planet, right? Now, sure. How we talk has so many more influences. How we were raised, who we were raised with, what our education level is, where we went to college, where we grew up. There's so many different things that make your voice and intonations unique that it's a much more difficult problem. Me and Mike kind of look alike, but we don't sound very much alike. Yeah. So it's a difficult problem. And then Blackness, and not to get existential, but Blackness is this diaspora, right? So people of color also is this very large kind of thing that there's so much diversity within it. And even whiteness. Yeah. There's no such, these concepts kind of, when you start talking about, especially in voice, they start losing their meaning very fast.
Yeah, and I've looked at literally tens of thousands of faces from the Middle East, and I'll occasionally see somebody that looks like they're a California surfer, blonde hair, blue eyes, pale skin. I mean, it's, yeah.
Okay. Let me share this real quick.
Tom actually said something in the chat. So why even do it? Every little step forward will be used to take us backwards. I had a conversation with someone the other day, and I was like, what a shame it would be if we never got face recognition right. How many people could we rescue from, sex trafficking with good facial recognition? How many times could we, early detect a stroke with good facial recognition? Like, there's so many positive applications of this technology that it's just like, we have to climb this mountain. We have to.
Yeah, and I think you'll see that, almost any technology you look at, especially if it's something new, has a bunch of downsides that come with it that we have to deal with.
So I wanted to start with, so I'm going to ask guided questions to each of the panelists, and then we'll open them up to the rest of the panel to answer as well and contribute to the discussion. So Mike, I'd like to start with you. We kind of started in this direction a little earlier, but why are models and data sets not fair? Why haven't we achieved this already? And what's the underlying business reason for them not being fair? And who defines what fair is anyway?
Right. So, that's a lot there. And I should first try to articulate something, because I think, like, my mom is watching. So, hey, difference between a data set and a model. A data set is what's used to provide examples for an AI system. It's also what's used to validate an AI system. So a data set might be pictures of cats with little boxes drawn around the cat, right? A model is that piece of software, or that construct, that's able to learn or discover features or react in a certain way. So you heard in Antoine's talk about different things with LSTM and all the different letters. Those are all different architectures of how you process and do some math at the end of the day. That will result in a model that's able to then go solve my problem in my space. So when we talk about fairness in this context, you have to really kind of think about it in the dictionary sense of what the word fair means. Like, fair is the absence of favoritism towards some group, right? So when I talk about a model being able to hit a benchmark that's, the top 1% or 99%, or it's 95%, accurate, whatever that means, that accuracy measurement is against some data set, some validation set. So when I say, hey, I got 99%, that's really good. But when you look closer and you start peeling back the layers behind all of this, you kind of find out the built-in constructs of the data set, that has to match up to reality. So if we kind of think about it, like you heard it a little bit in Alex when he was talking through the history of kind of how we got to face Reco in a certain way. Early data sets were really accurate and early models really accurate according to certain data sets. But that's because the data set was made up of people who happened to be at Stanford in the 90s or the 2000s, which might not represent worldwide people on the planet. But now that we've really recognized this as an industry, we're starting to pay attention to it, right? So the problem becomes, well, one, how do I create a really great model? But then secondarily, how do I go and create some way to license appropriately a data set, or give access to a data set to go out and build out this ecosystem that lets you grow both sides of that? Because you can't have one without the other, and you can't just kind of put something out and say it's great, right? You got to be able to iterate, and you got to be able to grow it. And to hit on the point Antoine made, right? We're going to make efforts, based as a business, right, on where we can make an impact. But it would be really cool if someone could take that and go bring it to a population that's much more bespoke, right, with a certain dialect or a certain language that's not necessarily in my list of 50, that's the top 50 in the world or something like that. So all of this kind of comes together in a way that really comes back to the control of data and the creation of data and labeling of data, and then trying to put as much transparency into the entire process, from that initial drawing of a box around whatever, or labeling as some text, to the final output, and tracking everything back and forth.
Can I double tap on that for a second?
Sure, of course.
As I think about, the first part of the question, like, why are models and data sets not fair? I really do wonder, like, what we mean by that, because oftentimes these narratives get out into the general public and it becomes about racism because the social contextual background of America always has this racial element to it. And because it was predominantly white and Asian engineers developing these things, obviously racism is the problem. It's funny that we talk about bias because, when you look at some of these data sets, it's not necessarily that they say, I'm not going to go get any blacks, but it's just like, did they have access to the technology that we use to capture it? And in voice recognition, what quality microphones were they using when we captured it? Were they on an iPhone 10 when we were listening to their voicemail, or were they on a Metro PCS? So that's not a racial thing. That's a socioeconomic poverty thing. So now poor people from all different dialects and all different parts of the state and country all over the world are gonna have lower quality. And so it's to solve this from a business perspective means that you have to reinvent technology from the bottom up to be data capturing. Then you get into the privacy component, because now it's just like, I remember that last year when I first started at Google, we were trying to get more pictures of color for Black people to improve the pixel camera. And then an article came out in Wall Street Journal and was just like, Google is stealing your face. And, and we had to fire the third party group that was collecting it and stop, because there's so much paranoia around data. So there's also this cultural thing of when we try to fix the problem, how do we do it? Do we communicate? Do we, and then how do we communicate this to the general public that I need this to improve an algorithm? An algorithm to do what? My grandmother would be like, no, get out of my face. And then we're going to say, why can't my grandmother open her iPhone 12? So some of it is us. And as a neuroscientist, I really appreciate this because scientific communication is terrible. It's been terrible during COVID, and it's even worse in the software engineering. We don't make an effort to get out here and talk to the general public about the why these things are. We just look like the bad guys behind the curtain. And so, I think a lot of this kind of gets wrapped up in so much of the social context that we lose the real engineering kind of, cause of it.
Yeah, I think an interesting example of that is I think it's Amazon's image classification, or might have been Google's, I'm not sure, misclassified a gorilla, a Black person as a gorilla, right? Which from a image object recognition standpoint is just another error that it makes like everything else. But essentially that was such a huge PR nightmare that they eliminated that from the model entirely. It doesn't classify gorillas at all because the cost of that incorrect classification was just too high in a PR standpoint.
Yeah, so I'd like to kind of segue into another question that we had. So, and this is open for everyone on the panel. What are some of the ways AI and machine learning systems greatly affect those from underrepresented communities? I think Antoine, you started to kind of talk about it a little bit, but I'd like to give you all some time to kind of deep dive more into how this really impacts underrepresented communities and why this is such a big deal. I think, most of the time in all areas of development and people outside of the tech space as well, you don't know what you don't know. So I think having the conversations and really bringing awareness to everyone will be beneficial for all of the different pieces that are required to make these technologies really work for everyone.
Yeah, as Alex brought up just a second ago, there are these high cost moments and then there are these low cost annoyances. My Google Assistant not being able to recognize a couple words I say because of it's like, okay, it's an annoyance, but it's not going to cost me my life. Whereas as these things start to move more towards medicine, and I'll stay there, as we start to use them for diagnoses, now we have a problem because voice recognition, one of the things that change when you start to get Parkinson's and other neurodegenerative is your control of your vocal cords. So if I'm building a training corpus and trying to identify people with early neurodegenerative disease based on read these sets of sentences, and I don't have a diverse data set, and I can't get people from underrepresented communities to even come talk to me about this, now they miss out on what is supposed to be a democratization of technology that allows diagnosis even without great medical insurance. That's what it's supposed, that's the promise of AI in medicine, is that everybody can access it, because once it's an algorithm, it's so cheap that you can do it on your phone. I'm grew up middle class. My grandmother won't take the COVID vaccine, right? She's 89 years old. She says, I'm staying in my house. I'm not going anywhere. I'm not taking it. I've heard anecdotal stories from our friends. So it's the same thing. As these technologies start to advance, what happens is communities are left behind. And then you start to see comorbidities and other types of health issues increase in our community. And that's really going to be an unfortunate outcome.
Yeah, I think that's a really good example, right? Because it kind of highlights the secondary or the tertiary effects of the problem, right? When you, as a group, start to opt out, right? Or when a system overlooks a group, that's when you start to see things that really cause, I think, subtleties in outcomes. And those are the most worrisome, right? That's actually one of the things that I measure my software on. It's not, we care equally about whether we got it right or wrong. When we look at something and we say that car was really a truck or a truck's really a car, we laugh at that one, right? But when there's really subtle differences and the software is not as confident, or the conclusion is almost right but not quite, that's what worries me, because those conclusions that are almost right might get hidden away in the massive flood of data. And if you can't detect that, then it just starts to snowball, and it becomes one more data point somewhere else in a system that leads to something, that at some point is all sourced back to this original problem. So trying to track that, or trying to measure that, or trying to identify those situations where there's these relationships that are not necessarily overtly in a data set, right? Like I can scrub a data set for things like demographic data to remove out race entirely, to make sure it's not one of the explicit signals in the data set. But if you think for a moment about picking up a data set that's great, there's no racial data in it, but if I accidentally happen to pick a sample of a population that just happens to have more black people than white people in it, or more white people than black people in it, that's going to cause other things to happen too, because people are different, right? And that's that whole point on bias in data and bias in models and all of that, right? So I think you'll start to see more work explicitly around trying to detect things like this going forward. And I think we need to have it as an industry.
Yeah, I can add just one real short thing to that. In the past few months, there's been two kind of famous cases of black males being falsely arrested based solely on face recognition evidence. Is that a problem with face recognition or policing? It's kind of a problem with both. The police are not using the technology correctly most of the time. They're not using it with enough oversight. But those are things we have to deal with. And that to me seems like a absolutely valid criticism as face recognition, is it can amplify biases already in the police department because of how they use it. Same thing with drug dogs and other things as well.
So I wanted to move into kind of exploring a little more about what's causing bias. So we talk a lot about data sets and problems with the data sets and bias samples of data. But is data the only problem that causes bias in AI models? And I kind of want to explore this a little bit more because, for instance, even with Google's Google Assistant software that so many people are using now, there's a lot of pieces and a lot of different areas of engineering and different pieces that are involved. So I kind of want to explore, what are the other problem areas in developing these AI models and even larger AI systems and software that different people working on different parts of it should be aware of.
So I have a couple examples off the top of my head. The first one, as I mentioned before, is just the technology itself, right? So as Google is trying to develop more voice models and language models that can actually process at the point of the device and not have to go back to a server, it really does require a certain level of device. So now you're talking about, top tier flagship phones and above. You're talking about top tier, maybe 5G networks. You're talking about places with, regular access to Wikipedia so the corpus can be updated. All of these things impact somebody's ability to access the technology, somebody's ability, the ability for the model itself to do its job, the quality of the microphone that you're using in terms of voice recognition. And then I think the other thing that comes outside of technology is the objective function almost. So by that, I mean, what am I asking the technology to do? I think that from an engineering standpoint, the types of problems you try to use it to solve, you have to recognize that some are going to be more prone to bias than others. So if you try to say, who here is a terrorist? You have to know that you're going to get some racially biased problems there. Who here is a criminal? You're going to get some racially biased outcomes there. So it really is a lot like putting limits on the types of questions we're allowing ourselves to ask and sticking around the ones where, as Alex brought up earlier, we already know that the bias is low and that the algorithms work well, and keeping those other use cases kind of on the shelf until we can use them safely.
Yeah, one thing I did want to share is when I talk to people about this outside of the field, I get the impression a lot of people think that the stuff we do is kind of like computer programming. When I write a program, I go through a list of steps of what I want the computer to do, A, B, C, and then if D, do G, and all this stuff. Most of these systems don't work like that at all. There's not a programmer telling the computer how to recognize voices or how to recognize faces. It's training a network how to do it. We don't have anywhere near the control we have in regular software.
Yeah, and that introduces a whole set of problems too. So let me paste my XKCD, there's always an XKCD for everything, right? But that you get a different source of issues, right? So in the case of training a model, if you haven't played with the stuff, there's this idea of building my data set, and then I'm going to show an example to the model, and it's going to get it right or wrong. And I'm going to tell it you did good or you did not so good. And it's going to do that over and over and over for thousands of iterations through the data set, right? That training process can actually introduce some really interesting problems like underfitting the data or overfitting the data. And that can introduce issues too, right? That can cause bias in a model. So in a totally different context, you might be able to detect a drinking glass. If I build a data set of drinking glasses, that's great. I can do that in an afternoon. I can train a model in a few minutes or in a little bit of time with the stuff I have at work. And I can try it out and it'll work. But as soon as I put the drinking glass on a wood table versus a concrete countertop versus some gravel or some green grass, that model is going to behave in a very different way. And it's because that model is going to do really good at whatever I told it to do. And if I don't have a sufficient training system, it may overfit to always look for the glass, which is clear, against, say, a wooden background or something like that.
And one, I keep muting myself. One more thing that hopped in mind, because it's come up a couple times in the chat, and I really want to provide some resources, is that at Google, we go through this thing, like when something breaks, we have this no fault system. You tell us why it breaks, and then like every time it's like, well, we probably shouldn't have left that to human judgment. Now we're going to build a system to automate to make sure that never breaks again. One of the problems here is that you almost need an AI testing fairness framework and system that just looks for edge cases, because what you're talking about is these conditional probabilities. Does the conditional probability change based on some level of some feature? And that is something that algorithmically can be. Now, in a language model, that could take quite some time to like train and run through, but we got all the money in the world over here, these big tech companies, so why not do it? I think like those are we really do need some automated framework for identifying biases after a model's been trained. I think that would really change the game.
Yep, and there's attempts to do that, right? I think there's a lot of innovation in the space in that area from different research institutions, and it really is around trying to source correctness in data, source correctness in validation, and then in production. And if any one of those falls out of line, pulling that back to fix it, right? We can pick up examples of all of these. Like, actually, I think I learned from Antoine's talk why my phone sometimes doesn't quite get me as well as it used to, because I switched it from American English to Australian English because it sounds the most like Jarvis from Iron Man. And I'm pretty sure the language model shifted very slightly, which now that I say these words makes sense, but has been explaining the last 6 months of little oddities I've had with my phone, right? So stuff like that's going to keep coming up. And the correction for that, like the fact that I'm a North American neutral-ish accent person using this thing, is probably introducing data points back to Apple in this case that is going to mess with someone's day, because it's going to be an outlier. It's just going to be there, and they can't deal with it, right? Or it's not what they're planning to deal with when they pick up their cup of coffee in the morning.
Yeah, and that was actually going to be my next set of questions was, how can you detect and reduce bias during development, and what are some techniques for reducing bias in AI machine learning models? Antoine, I saw you answer something in the chat a little bit ago. I know you said it wasn't open source, but maybe you could kind of talk about what you're working on at Google, or what Google's working on to mitigate this.
So we have an entire kind of AI fairness toolkit and package and things we're supposed to do. First is there's an entire office for us to get help with unbiased data sets for very large problems, especially for things that are going to be consumer facing. So open source data sets is one thing we can do. Open source diverse data sets is one thing that we can really do. Detecting bias. So as Alex brought up, you have to do it. Actually, I think, I'm sorry, it wasn't Alex, it was Mike. You have to do it at multiple points in the pipeline. So you have some target, and you have the different levels that you think bias may exist at. Now, the problem is once you start combining these different levels, because it can't just be race. It has to be race. It has to be where you're from, social. All these informations, we might not have. That's the first thing. And now you have this multifactorial element that expands exponentially when you start talking about where I'm looking for bias at. So if you're just looking for racial bias, okay, that's a much easier problem to solve. But what about ability, right? When now we're talking about disabled people, now we're talking about autism, right? So is this even information that we're collecting? And so, detecting bias, the easy one is race, because you can see it. All the other ones that require, more information to understand why your outcome may be kind of tilted or less performant for one group of people, is completely dependent on you understanding who that group of people is in the first place. And we simply may not. You're not going to put that you're Creole in, an intake form. And so that's, it's tough. It's because it bumps up against privacy. How much do you want to tell me about yourself? If you don't want to tell me a lot about yourself, then I can't guarantee that this is going to be representative for you. And so it's a chicken and an egg problem, and it sucks that that's where we are. But I think what we really need is some framework that gives people a better privacy framework in this country, that gives people peace of mind knowing that this information is being used to improve products for them, and not and I didn't even answer the question. I'm sorry. We have tools that kind of go through, like I said, that kind of go through your data sets and go through your outcomes and kind of weigh. You have a target function, and you say, okay, you know, what type of bias are you looking for, right? So you'll give it a couple columns where it'll look through and say, okay, across the different levels of this feature, are there any discrepancies between, you know, any large discrepancies between the accuracy of your target metric? That's kind of what we're doing right now. Is basically like data slices. It's not very sophisticated at the moment, and it's not very sophisticated because of the things I just listed.
Would anyone like to add to that, or I can move on to the next question?
Well, there's so I put in the chat the trust, or the AI Fairness 360 thing, that is kind of another approach, right? And like I said, there's multiple people all trying to come at the same problem, and that's the great thing about the research, right? Is that everyone levels up their game. There's also kind of a separate set of questions that I think become really interesting for not the AI software people in the room, not the data scientists, but everybody else that's in the room, which is, how do you leverage this stuff in the context of trying to do what you're trying to do it in a way that's going to please your users or your customers, and also, by the way, still be fair and everything we just talked through. So there's kind of a structure that you can kind of use to think about this, which says, hey, one, what's the problem I'm trying to solve? You have to articulate that first, and be able to say crisply that. But then what are the sources of data that you can get for it, right? And what are all the different ways you can get that? And then the great part about this exercise, which is what we do internally, is we actually write down all the ways that if I put these things together, things will go wrong. Like, what are all the bad things that will happen if I put together the loyalty data and outside third-party, you know, information, and this and this and this? What is every possible bad outcome? And we'll try to think through it as just people and say, okay, well, that's not good. So let's remove this source and let's explicitly try to insert checks for this kind of thing. And then once we have that, then we can start looking at, well, okay, how can I put this into production in a way that we can actually measure and instrument it and try to see, hey, is it actually working okay? And then when it is not working okay, because it's inevitable, go back and fix it. So that kind of step-by-step thing, that's something that we're figuring out as an industry. And I think everyone's done, like Google has the same thing. Like you heard from Antoine, he has a process he has to follow when he does something, right? And I have the same process, and I have the same checklist. We have an ethics board, and you know, all that stuff is in there to try to put together this in a way that we can still deliver function and get it done, but do it in the context of the broader team. That's the application team, or the users, or the folks that are not the ones with the PhD in the room.
So I wanted to ask two more questions, and then we'll get to some of our Q&A from the audience. And these are, I guess, less technical questions. So the first question I'd like to ask is, where do you see the engineering market heading in the near future in the new wave of AI technology? So where do you see the tech space moving into this new era of AI technology moving forward?
Man, that's broad. Yeah, that's tough, because like I hate making these types of predictions because I'm always wrong, because something new is going to come out next week. It's going to be like, oh, nothing you did last year mattered. I see specialization becoming a much bigger thing, and democratization. I think that we're going to see the advent of a lot more point and click AI that allows a lot more software engineers without the heavy math background to actually be able to leverage AI more in systems. And then I think you're going to see more kind of research science folks developing the new architectures.
Yeah, I could definitely back that up. We've started using the Google Coral device. It's a TPU coprocessor thing for just some general computer vision tasks, and it's almost as simple as just calling a software library. You know, you basically can plug this thing in and get inference and detection and all kinds of stuff practically for free. I think we're going to see a lot more software that adapts to humans, which is great. Like your Ring doorbell can tell that the Amazon guy is leaving a package on your door and notify you, for example. You know, but I think it'll be a lot of cases where computers are trying to figure out what humans are doing so that they can adapt better to them.
Yeah, and my job is to do point and click AI. That is literally in my commitments to the business. Absolutely, our whole goal is to take problems that are in the realm of science fiction and show the appropriate ones that we can pull into reality. So what we're doing is we're bringing, for vision particularly, a set of different models out that I can customize to my specific use case. So if it's detecting bad welds or quality issues for auto manufacturing or what have you, that are specific data sets, specific issues, they're not going to be in a general purpose model, right? I need to know that this has 5 bolts on it, not 6 bolts. Or I need to know that there's a cracked thing or the wrong one or that kind of stuff. You're going to see that more of that specialization happen, and you're going to see more products that are leveraging these things that are tuned, that are fit for purpose in a context. If you use WebEx, our colleagues from Cisco, they've just added the WebEx Assistant in, and it is comically almost good and comically really good sometimes, and it's going to evolve. So you're going to see these things show up, and you're going to see them because of that whole retraining process that Antoine mentioned, right? You're going to see them start bad and then get better over time. Like, you may not remember the first time you got a home assistant, if you got one several years ago, where it just could tell you how to do a timer, and it could maybe look up something on the internet. And if you would ask it anything interesting, it would say, I don't know how to do that, or it'd give you a random song off Spotify. Now they've gotten to the point where the combination of the software has evolved to meet up where I can bring this speech analytics that Antoine works on, and I can combine that with computer vision stuff to say, when a user taps on this and says, what was that, right? The combination of the speech plus the tap on the screen, that's a super powerful thing. And it's so subtle, right? That's such a subtlety that we can't really do yet, honestly, right? But that's going to start happening more and more and more.
And Mike, I know we always have a handful of people that are coming to these events and kind of trying to fit their business use case, the information they're gathering into their own personal business use case. So I wanted to ask you, here we go. So since you work on computer vision, what are some examples of bias that you've seen when working with customers? And Alex and Antoine, maybe you have examples as well for anyone that's looking into AI machine learning implementations into their own, maybe their own business or platforms they're working on.
Yeah, no, that's a good question, right? So we because of the topic and the subject, right? And we talked about bias in the context of race and all of that, but we could take that to a different source entirely. So my favorite example is actually something we put together for the U.S. Grand Prix. So I'm in Austin. There's the Circuit of the Americas track down the street. We're going to hopefully host the US Grand Prix here in the fall. And we took some video from that and built up a use case around advertising. And the thing was detecting the 20 different cars that are on the track, detecting the advertisers in the background. And we could build the model, and it did really good. It built a great demo. It looked awesome. But when you look closer at it, going back to my point about the subtle incorrectness, right? It actually had a bias built into it. And the bias there was that it thought that any F1 car that was shot from the front or back, so like a chasing shot kind of thing, with the sun like shining on it from just the right angle, was a Mercedes. And that's because when we went back and looked, because I labeled it, because it was just my thing, doing it in like an afternoon, I just picked every third second, I picked a frame out of the video. And it so happened that the video I picked was a highlights reel that was telling the story of the battle between Mercedes and Ferrari and Red Bull. And they just had a bunch of chasing shots back and forth. And I just labeled too much stuff with the Merc in it, right? So that kind of thing can show up in other places too. And that's, we laugh at it in that context, right? But that's still a bias in a data set. In a manufacturing context, it's the same thing, where a system might believe that this is busted, but in reality, it's good. It just has a weird shadow on it, right? Those things will show up, and you still need that same sense of detecting fairness or detecting bias or drift in that context.
Yeah, I can share one from the old days of AI when I used to work in the military. We used to always talk about an example where they're trying to train a system to detect Russian tanks and American tanks. And it worked really, really well, in their initial, this is some of the early days of computer vision. It worked really well. And then they quickly realized that all of the American tanks were shot with bright lit, good photograph quality, and all the Russian tanks were kind of grainy and black and white and everything. So what the system learned was how to determine the difference between a grainy black and white picture and a bright color picture. So a lot of times the systems will do what we tell them to do, but not what we meant them to do.
Oh yeah, no, I have that same thing. I mean, I actually built if you watch Silicon Valley, hot dog, not hot dog was a thing for a hot minute, right? So I used my stuff, went and got a data set from MS Coco that happened to have hot dogs labeled in it, yanked it in, trained it, thought it was brilliant, and realized what I had built was not a hot dog detector, but rather a bun detector.
Yeah.
Right? Like, again, makes sense, sort of, but you need to be able to define that.
Yeah, these are, these challenges are the things that kind of scare me about, democratized AI, because I think the real challenge in AI in the future is not going to be, do you understand how to, make your own custom architecture? It's going to be like, do you intimately understand how to build a training set that actually does what it is you're trying to do? And do you understand all the things that could impact that? And I think that is a level of domain knowledge that even software engineers tend not to have. You brought up the example of the 5-volt versus the 6-volt for welders. A welder would know that. So maybe my fears about democratized AI are misplaced, because me as an engineer, I would totally miss that. But somebody that had domain expertise in that field probably wouldn't. So maybe, I just proved my own point, and that getting this technology in the hands of people with the most domain expertise is actually the way to create the best models.
Well, I think so, right? Take Excel as an example, right? Or spreadsheets as an example, right? Like there's the adage of there being lies, damned lies, and statistics. And I have a graduate level book on statistics somewhere, of which I know about the first quarter of it, because that was my entire course. And even that, I sort of don't really get it exactly. But we still see that with other domains too. So if you want to go argue on the internet, you can go argue on the internet about data left and right, and everyone's going to have the same data sources. And they're going to go into Excel and they're going to slice it up, and they're going to get an answer with a little graph that does something. And they're going to say, I'm right. But I can apply a different technique and say, no, I'm right. And that still is it's gonna keep happening, and it's gonna be the same in this space too.
Yeah, there's a classic misstep the police made with face recognition where they somebody told them the suspect looked like Woody Harrelson, so they put a picture of Woody Harrelson into the face rec system, and they got the right answer. Which is one of those weird cases where it's like, okay, they didn't understand the technology at all, in order to understand why that was a bad idea. So I think, yeah, the democratization scares me as well, because I think a lot of it I've seen, where it's like, oh, all you need to do to create your AI model is point and click and drag some things into a folder and stuff like that. And that misses a lot of the nuance in how this stuff works.
So I wanted to ask some of the questions we have in the Q&A. So I'm kind of going through some of the ones we've already answered or talked about the general context. One question I would like to ask, we have someone asked, could synthetic data be used to train out bias? And what do you see as potential pitfalls or positives?
I've tried. I've tried. It has not worked. I mean, the methods just are not there yet. At least in and this goes for across tabular data all the way to voice recognition. The problem is the methods that we're using are really just not sophisticated. They're kind of just like fill in vector space. And that in and of itself kind of just gives you a mishmash of the same thing, but not really something that you'll see in nature. And the whole thing about synthetic data is that it needs to be able to mimic something you'll see in nature. So if you think about what a Markov model does, or even Bayesian statistics, where you're really trying to estimate a probability distribution, you're assuming that because you have X amount of features, that the distribution of those features across, is going to follow a normal distribution. And if you take the distributions of a bunch of features, you'll get some type of Gaussian mixture model, right? It just doesn't work like that. And in the reality, and even if it did, that doesn't mean that the data that you're going to get, that the model is going to see, is going to represent any of the data that you just came up with. So it hasn't worked for me. But I do think that there's one example where I am seeing it work. Self-driving cars. So in Waymo, I actually just saw a presentation where they are doing they've run our AI through millions of miles of simulations where they can just randomly have somebody walk across the street or change. But that's because they have a fixed number of parameters that they're just randomizing billions of times. And in those situations, actually, it's been pretty effective, but that's not really a bias outcome.
Yeah, one place where I've seen it, it looks like it could be effective, we haven't tried it yet, is you basically, if you're trying to recognize, say, a box of cereal, you use an artificial background environment, like in Unity, to constantly change the background to different scenes so that the algorithm can learn what is the cereal box and what is the background scene. Seems like it could work. But again, we haven't tried it. We have looked at synthetic faces, which is our cool technology that's come out over the last few years. You can generate infinite number of synthetic faces, don't have to worry about privacy, anything. In theory, those could be used to create a better training set for face recognition that has the right demographic distribution that you want. Like Antoine was saying, it might eliminate some of the demographic bias, but it's going to probably introduce its own bias tied to how those faces were generated synthetically, which for faces, they're kind of cutting ears and noses and reassembling faces that way. That's not a normal process. So there's potentially biases that you're introducing there that are going to be even more mysterious than the skin color biases.
Right. Yeah. I've actually seen a startup at South by Southwest, not last year, I guess, but the year before last, that was doing something where their whole thing was to help with self-driving data sets and address privacy issues. So their pitch was, we will look at your driving data set, find a face, and we will replace it with a generated face. So I can get my data set, which is what matters about the vehicle and the landscape and stuff. I don't have to worry about privacy concerns of the person that's in the set. And that's a good idea. And I think that kind of stuff can help within our own stuff. We do data augmentation as a built-in just feature. But augmentation is different from synthetic. where augmentation says I'm just going to take the image and flip it or rotate it or put some noise on it or zoom it or something like that. I'm not going to go and create a whole new thing. I'm not going to go change the season outside from spring to fall. That's a very different thing, and that's extremely hard.
Yeah, I mean,
yeah, Mike brought up a point really important to us that we're starting to investigate is this use of, I guess, adversarial networks to generate faces that look the same to humans but don't match algorithmically, which is kind of a really cool use of technology. It's almost the opposite of what we normally do. But what you can do is you can basically make a face that for a human to like review a transit log or something like that, they would be like, oh yeah, that's Julie or something. But if it was fed into another algorithm, it wouldn't match Julie's face. So that kind of technology that can preserve privacy and still let us get the job done is really wonderful.
Yeah, those are really cool applications. I mean, from a sci-fi perspective, I'd love to see, this combination of a use of like genetic evolutionary algorithms like we use in like bandit algorithms and combine that with general adversarial networks and say, show me black faces that actually kind of originate from this source code of what a black face is, and not because if you have the corpus and the corpus is good enough to make a black face, then you could have just put that in a data set in the first place. The idea is, can we make new ones,
right,
ones that are naturally feasible? And I think that's the challenge.
Yeah, and it's a computation problem, right? At this point, the field took off in the 2000s because some really clever folks figured out how to use gaming parts to go do a thing, and now there's this race to throw more and more and more resource at it, to the point where models like GPT-3, which if you go look it up, is this great text thing that can complete sentences and answer questions and do all sorts of really unique things. It is cost prohibitive for anybody to go build one. Like, I can get the data eventually, but if I want to go make my own version of it, I'm going to spend millions of dollars to go do that in power and in resource and time.
I wanted to follow that up with, so someone asked, we've been talking a lot about training models with data sets, but once a model has been trained with a data set, can it be untrained if the data set turns out to be especially problematic or inaccurate?
No, not that I know of. I could be wrong. I think you pretty much have to, I mean, there might be some super sophisticated way to like remove that data from the weights, but from a neural network perspective, not. It's because it's a bunch of matrix multiplication. And so I don't know how you would kind of reverse that for one specific data set.
Yeah. For us, we just throw it away.
There's transfer learning. I don't know if that would fall into that category where you can essentially just train the last layer of a network. You could use that to remove an item that was problematic potentially, but yeah, in face recognition, that I don't even know that would make sense.
Yeah, the problem with transfer learning for object detection, as an example, though, is if I start with a model that's learned some features, right? It's got this. A deep learning model has layers to it, and the techniques we're talking about, right? Mm-hmm. So imagine 70 layers of stuff. That's matrix math. When I train the thing end to end, I'm going to learn features at some parts of it that detect edges or maybe understand the typical things that might be like, what is the prototypical definition of the edge of a class, right? I don't label that, but it figures it out, and it figures out that if I get a little bit of this, a little bit of this, and some of this, and not that, then that's going to be a drinking glass. Even if I transfer learn and remove drinking glasses from the final output, the model will still have that innate knowledge in the structure of it, of what that stuff is. Mm-hmm. So that actually leads to another problem, which is this idea of lineage of data and lineage of the model, and all of that just becomes yet a different thing to track and a different thing for people to know, to even ask about when they're doing stuff.
Yeah, I think it's important to know, though, that for most of these systems, they can't explain themselves at all. If you're like, why did you match this person to that person? Why'd you call that an apple? You know, there's nothing. You can't audit the code. You can't debug it. You can't do anything.
So Alex spoke about human bias versus computer bias in facial recognition software. What's the difference with voice? Do humans tend to be more or less biased than the technology?
In terms of recognizing someone else's voice, oh man, I wish I had some compelling research on that. So I'm not going to speculate. Just from a reaching on my, only tangentially related neuroscience background, I think the thing with familiarity is we lock in things we're familiar with, and everything else kind of just sounds like noise. So I know my wife's voice, within the voice of a million people, but a million other voices just sound like a million other voices to me. So that would be my expectation, that our brain, the parts of our brain that recognize vision and they recognize speech are pretty similar in terms of how they process information.
Yeah, I did want to elaborate on one thing. Every human is racially biased when it comes to face recognition. And that's been studied pretty extensively. You're biased to the people you grew up with. So like if you were a baby adopted from China, you would recognize Caucasians really well. It's just whatever was around you when you were a formative baby, those are the faces that you recognize better than other ethnicity faces.
Someone asked, how do we address bias against people with disabilities? Now, I know, we're limited to the access to the data sets we have, and it's probably even less with more marginalized groups. So how would we address that problem?
First, I want to just drop a little neuro-linguistic thing in here. Like, I think by definition, like bias against is the wrong way to say it, because it's not intentional, and it wasn't built. It's almost a passive thing, right? So how do we address bias? I think the thing is like, you need advocates in the room, and because Google does do this, right? We say we're building for everyone. And so it does go to a panel and say, okay, like throw out, can this group use it? Can that group use it? What if they're this? What if they're that? And is it accessible? And how can we make it accessible? There is an attempt to do that for every customer facing product. Sometimes we're just not able to. And other times, like with Project Euphonia, it actually spins up an entirely new research, group just to try to solve that problem. But we need disability advocates in the room, because I don't know anyone with autism. I wouldn't know where bias would present in an autistic population, whether it be voice or any other type of data. So we really do need, and unfortunately, a lot of times we're not gonna know until it happens. And what really sucks is if those people don't have a way to reach out and kind of make noise about it, then it may never get fixed. And I think one thing we need to do is go out there and proactively seek out instances of bias across certain groups.
Yeah, in terms of identity, the core identity technologies are face, fingerprint, and iris, and sometimes voice, but it's mainly face, fingerprint, and iris. And of those three, face is the one that's the least sensitive to disabilities, because people that are blind a lot of times won't have usable irises. People that have coordination issues won't be able to use a fingerprint reader. But about 1% of the population doesn't have fingerprints at all. But in general, face is the one that is across anybody with any kind of disability in terms of identity.
That's very interesting, because obviously it's not something that most people think about, but that's interesting that if you take away all of the options, that face recognition is kind of the one that is the most accessible.
Yeah, it's also the one that's the easiest to use for mass surveillance, so it has pluses and minuses.
Right, it's kind of on both ends of the spectrum at the same time.
Yeah, When we started working with this 15 years ago, we couldn't reliably identify Down syndrome kids because their faces were just differently shaped than the training sets. But that's all been fixed a long time ago.
So that's a good segue into our next question. So, and Mike, I know you had spoken about this a little bit last year on the panel. Shouldn't there be some clear standards that govern the technology, that it should be race, gender, ethnically neutral, so people are not punished by earlier prototypes? This was the question from one of the viewers. And I know last year when we kind of touched on this, you were talking about kind of the pros and cons of regulation, how it can, how it impacts what you're able to do and with the technology.
Yeah, I think that regulation at the point of putting something in production is absolutely critical. Regulation at the point of doing fundamental research is critical because of, again, that idea of having validation points along the way. The tension there, which is I think a healthy tension, is the tension between that sense of privacy or that right of use of data and how that can go into making whatever problem a problem that can be solved or not. It's something that we see glimpses of in things like Europe's GDPR or California's CCPA and that ownership over right to use and stuff like that, right? Or right to be forgotten. And it's something that frankly is going to have to evolve in everything we're talking about here. This is part of why for my team, we focus on industrial use cases. Like we explicitly in our governance do not do face reco, face ID stuff. Like it's part of IBM's standards that we don't do it. We actually put out a thing last year on that topic. When we do choose to do things like that or go into something that's adjacent to it, it's with very, very, very explicitly laid out steps. So for my team, we actually do industrial use cases because, I can go get pictures of bolts and door panels and stuff like that, and be able to still address the same kind of fundamental problems, but it's much easier to do. The societal stuff, though, that's really hard to address, and that's going to be something that we'll be wrestling with, and it'll probably end up resulting in new or different laws over time.
So I wanted to take one more question from our panel and then kind of close with final thoughts. So I think this question is extremely important, especially now with the way that things have made this shift to everything being virtual. So someone is an education advisor and advocate and that's attending, and they asked, what are the implications for public education? Is there a way that bias in some of the standardized tests can be eliminated or lower? Don't know if this is the best question, but I'm interested as an education advisor.
I think a lot of this stuff kind of depends on the context of how the technology is being used. I mean, in our system, people volunteer to enroll themselves by taking a selfie, and then they get to test the system when they walk by our sensor and it works, and we'd know immediately if it didn't. So, I mean, it's hard to see in that situation how somebody's being left out. I think in other situations it could be, but I know there was some issues with face recognition being used for test proctoring, and that had an educational impact, and I think people of color were being more likely to be flagged by the system as being cheating or something like that. So, I mean, there are issues like that do come into education. I think it depends on the context of what technology and how it's being used.
Yeah, I don't, I just go back to what I said earlier around like high stakes, low stakes use cases. If we have something that's working right now, like standardized testing, I'm not, unless it's, unless AI is adding much more value to a much bigger group of people, then I would just keep it away from it, because there's always going to be some drawbacks. And unfortunately, where there's consequences of like somebody may or may not get into the college of their choice because we're a couple years from improving its data set, you just don't want issues like that. Now, from where now, one of the things I'm passionate about and hopefully one day can get into is, customized, personalized learning using AI. Like what is somebody's learning method? And can I adapt a course or a set of questions or your homework to improve, your performance on tests? Now, even that has problems. Am I teaching them to be great critical thinkers, or am I teaching them to be great on tests? I don't, there's all these things, but I think the things for AI really come from a lot of what I focus on is like, how do we help people and get away from this discriminative AI, which is like, how do I tell the difference? And start using more of the generative AI to say, okay, how can I improve what this individual is doing or how they're performing?
Very good. Thank you. So I wanted to kind of close out with our last question, kind of taking into account everything we've discussed so far and the current events of things that are going on, not only in the U.S. but globally, and how things are. There's been a huge shift and a lot of changes within technology just in the last year, with everything switching to virtual. A lot of experimentation going on. So I'd like to close with asking each of you, what needs to change within our society to push for more equality and, more importantly, more equity within technology?
Man, you love these big existential questions, don't you? I'll let you tackle that one.
Yeah, I think the thing that jumps out to me, and this is something we struggle with all the time, is that technology, at least in my experience, and maybe some of the panelists, is still so dominated by white males. I've met like 1 or 2 female programmers in my entire career. And it's just that's got to change. For any of this stuff to really change, we've got to get more diversity in the technology field.
Yeah, having someone in the room, as Antoine put it, is important. That's part of why I do what I do, because it's one, I find it fascinating, and 2, I get to do things like this to go hopefully help people understand that they can go solve really interesting problems and do stuff in the space. The big thing that I think goes with that is understanding what's the implication of using the tech, right? Understanding why this is important to talk about and why opting out has an implication on what you're doing, right? So like for me, I choose to opt out of things for privacy reasons, but because of that, my data is not going into making the model better. Mm-hmm. So I need to be aware of that. I happen to write the stuff, so I know how it works, but others may not be. And I think it's a really important thing to highlight where these actions have consequences. So like you actually kind of see that a little bit in things like fact sheets or like almost like an AI nutrition sheet or something like that. There's things coming out along those lines. You're trying to lay out some of the stuff, but they're not really there yet. And we're not trained as a society to go look for that kind of stuff yet.
Yeah, I think Mike needs to be successful. And in that, I mean, democratization. I'm a big believer that, early in my career, it was like, how do I get more African Americans into tech? And then I showed up in Silicon Valley and was like, nobody I know would want to be here. So we can be alone and isolated and look that crazy on every corner. Like, yes, the idea can't be that like people of other races have to go fit into this thing that wasn't built for us, that is hostile towards us. We have to bring that technology to the people. We have to make this technology accessible to, artists and artisans. African Americans in this country are amazing culturalists. We drive the culture forward, whether it's music or clothing or cooking or whatever it is. Why am I asking them to be a software engineer? I need to enable them to leverage, software and AI in order to drive what it is we do. So, I mean, we need to bring technology to the spaces these people are in and stop asking them to come to these spaces.
Yeah, exactly. I couldn't agree more. I just want to give a big thank you. Oh, something's frozen. But I would just like to say thank you to, thank you so much to everyone on the panel. Thank you so much for all of you for coming. I'm trying to post in the chat, but it seems to be interesting. Seems to be not exactly working for some reason. Oh, okay. Sorry. There was a tiny message at the top. So I'd like to thank all of you for coming. I'd like to thank all of the panelists so much for taking the time to come out and spend some time with all of you and answer all of your questions. I know that Dr. Antoine gave a lot of great resources. I'm going to add those to the slide deck. I wanted to just mention there is a feedback survey. It's a 2-question survey. It's not like a big thing. You don't have to give us any information. I just posted the link for that. And if you would like to stay connected with everyone and follow us on LinkedIn, I've included everyone's LinkedIn profiles. So if you'd like to follow us and continue to stay connected, you can feel free to do that. I've also aggregated, here's the link for the survey. Again, it's in the chat. I've aggregated all of our resources here for you at the end. So I have some great resources from Antoine about voice recognition. I also have some AI ethics resources from Dr. Fatima that wasn't able to make it today. And then I have, of course, the data science certifications that I mentioned earlier. And feel free to connect with us on our IBM Developer social channels. Again, I want to just say thank you so much for all of you for joining. I know it was a little tricky for some of you with the power outages and things that are going on in Austin. And I hope that this was beneficial to not just everyone that came and joined our panel discussion, but for the panelists as well. And I hope that we can continue to continue this conversation as we go forward. And if anyone would like to say anything before we go, feel free. Otherwise, we can.
Thanks, everyone. Absolutely great. Great conversation.
Thank you all so much. So we're going to give you all a second to close out, and we will see you all at the next event. Thank you so much.
Thanks, Jen.
Bye. Thanks, everyone. Stay safe, stay healthy.